when would you call India as a indigenous developed air power?
One is we need to have an indigenous fighter. Second, we need a indigenous transport aircraft. Third, we need an indigenous unmanned aircraft. And fourth, which is a pillar, is the indigenous engines.
So when you look at it, all these four points require to be Atmanirbhar in the jet engine category.
Yes.
Why do we need to know and maybe worry about the jet engines, the indigenous jet engine that is Kaveri?
India has been trying to become Atmanirbhar in aeronautics technology for a very, very long time. The Kaveri derivative engine is an engine without the afterburner. Problem with the derivative engine is RP-IDSA program itself has not been approved. If we don't launch Kaveri Mark II or Kaveri Mark 1.1 or Mark 1A, we would be doing it. Even inaction would be a mistake. If somebody can track your position, somebody can track your communication, your intent gets compromised.
I want to understand from you your perspective on the change that you have seen over the last 20 years.
Huge transformation. The challenges I believe are still there, but the attitude of Indian stakeholders has changed a lot. But I feel still they do not understand the technology trajectory of success in aeronautics program.
We haven't seen an unmanned fighter jet yet.
It's not easy to replace a man because
there's a quiet revolution happening deep within the hangars of Indian air power. It's a story of missed opportunities, resurrected dreams, and a growing determination to ensure that India not only flies, but flies on engines of its own making. Today, we speak to someone who has seen this transformation unfold, from inside the cockpit and from within the corridors of India's air power strategy. Group Captain R.K. Narang, a retired Indian Air Force officer, a respected thinker on aerospace technology, and the author of the book, India's Quest for UAVs and Challenges. Group Captain Narang has spent the last 2 decades closely tracking India's ambition in jet engine development, 5th generation fighters, and unmanned systems. In this conversation, we journey through the history and hard lessons of India's aero engine development, with a deep dive into the Kaveri jet engines, its promises, its setbacks, and the technical breakthrough that are finally bringing back into relevance. We explore why he believes India is finally emerging as a developed air power, progress in LC Tejas, AMCA, and the distinct challenges of developing a naval fighter. We also talk about aerial data networks, the implication of 5th generation fighter jets, and India's air power capabilities. Most importantly, we ask, what will it take for India to achieve true sovereignty in the sky? This is a rare episode where technology, policy, strategy, and indigenization converge. One that tells you not just where India stands, but where it must go. So without further ado, let's get started. Before we dive into today's conversation, I want to take a quick moment and ask for a favor. We noticed that 93% of you who watch our content regularly aren't subscribed yet. My promise to you is simple. If you hit that subscribe button, we'll keep working hard to bring thought-provoking conversations, incredible guests, and the topics you really care about the most. It is practically free for you, but it makes a huge difference for us, helping us grow, reach more people, and bring even better content your way. Thank you for supporting. It means the world to us. Now let's get back to the video. Group Captain Narang, welcome to Dive for Publisher. An honor to have you here with me today.
Thank you very much. And thank you for inviting me to this podcast. And I hope we have a scintillating discussion on some of the very important issues which we are dealing
Look forward for it, sir. Today we're going to be speaking about our indigenous jet engines and what the scope is for the future. But before that, I want to understand from you the importance to understand the subject. Why do we need to know and maybe worry about the jet engines, the indigenous jet engine that is Kaveri?
See, remember, India has been trying to become Atmanirbhar in aeronautics technology for a very, very long time. If you see, our first project was HF-24, which was launched in 1954. And why we did not succeed in a Marut program was because of engine. We were trying to get those technologies, and we realized much later that if we want to succeed in any program, it will be jet engine. And now why it becomes even now important is India is aspiring to develop wide-ranging aeronautic systems. So you look at LCA Mark 1, LCA Mark 2. We have a plan for twin-engine based fighter. Then we have an advanced medium combat aircraft, which is a fifth generation fighter. So this is only the fighter program. Now you look at our helicopter program. We have a ALH, advanced light helicopter, LUH, LCH, and in future we have a IMRH and maybe such aircraft in future. Now go to the trainer aircraft program. We have HTT-40 and we have a intermediate jet trainer. And in fact, we are going for HLFT 42, which is a Hindustan lead in fighter trainer, futuristic fighter trainer for the defense forces, Air Force especially. Now let's go to the transport development program. We are trying to develop Saras Mark II. Then we have a regional transport aircraft. Then we have missiles program. The scope is humongous, and India largely imports these engines. Now remember, so much of money goes abroad, but engine is a very specialized capabilities. So if we have to really succeed, then half-hearted effort, or you're reaching close to a milestone and giving up and trying to reach the next milestone, they don't succeed. You need to fail in a manner that you have all the data with you. So the way we fail, we have to change. Failing is not bad, but the way we have to fail, we have to change that. So it's a very important subject, and it becomes even now important because not only I spoke about fighter transport, helicopters, trainers, but now we are going to another domain of unmanned aerial vehicles, unmanned combat aerial vehicles. So the bouquet is huge, but we need to take ownership of aero engine technology, and it will not happen on its own. And also we have a tendency of shifting the goalposts. When you don't achieve something, shift to the next goal. We have to be careful about it, that we don't shift in a manner that we do not incorporate the lessons learned in our last project. So that part has to be kept. So it's a very important part. We have to really understand the nuances.
As an ex-serviceman, where does your interest in the subject come from? And you seem very passionate when it comes to bringing change or bringing, inculcating emerging technology into our defense forces. What is your purpose and passion on the subject of this indigenous jet engines or even national security?
So, as a defense, I'm a helicopter pilot by profession. I still have a license. I deliberately decided to get into this field because I thought it is an area, it's a vacuum area. I need to put my energies into it. And frankly speaking, I'm not the best qualified person to be here. It was thanks to the Indian Air Force when they sent me to Center for Airpower Studies in 2014 for a study on UCAP. But the learning under my seniors, we had our Director General, Air Marshal Patni, then Air Marshal Nohar, the learning by itself, AVM Bahadur. They were the people who taught us how to do research. Then I hired my immediate seniors like Group Captain Vivek Kapoor, my peer Vinko Nijjar, and my supervisor, Air Commodore Bandopadhyay, Group Captain Chatwal. These people taught me how to be meticulous and go deep into it. And Kapoor sir is like a mentor. He taught me what Indian aeronautics industry is capable of. So once you understood the potential of Indian design, development, innovation capabilities, and I also had the privilege of interacting with DPSUs, with the private sector, academia. In fact, in my current position as a senior fellow in Manohar Parrikar Institute of Defence Studies and Analysis, we have our Director General, Ambassador Sujan Chinoy. He himself is a very passionate person. So having interacted with so many people looking forward to India becoming a developed nation in aeronautics, I think it becomes our duty to, be a small contributor.
When would you call India as a developed, indigenous, developed air power?
So if I have to really look at the benchmark, upper benchmark, I think we will need three uh, technologies, four technologies, I will say. One is we need to have an indigenous fighter. Second, we need a indigenous transport aircraft. Third, we need an indigenous unmanned aircraft, which is a combat aircraft. And fourth, which is a pillar, is a indigenous engines. So these four. Now, remember when I'm talking of a fighter aircraft, LCA has achieved or probably will achieve a status of a Marut. Marut we built about 146 aircraft. So let's say it goes to about 150, 200 aircraft. That pillar, if it does not, it has to really succeed to the next level. We should be able to develop, let's say, LCA Mark II or AMCA, which should have, evolution in the trajectory of at least 2 or 3 variants coming up in their life career to really become a backbone of Indian Air Force. Then I think we will achieve, and we would have developed our own transport aircraft. Helicopters we are doing well, but we will have our indigenous engine in that, indigenous engine in all these three at different capabilities. I would have achieved. And the fourth one, our
Jet engine itself.
UCAB. So I think these are my ultimate.
So when you look at it, all these four points require to be for us to be, Atmanirbhar in the jet engine category.
Yes.
And that is why I feel it is important to speak about it in depth. So, but before we get into the indigenous jet engine, that is the Kaveri, in depth, I'll also ask you about the history. I want to understand from you your perspective on the change that you have seen over the last 20 years. Are you hopeful, and are you happy about the change that the ministry and the services have gotten themselves when it comes to bringing in the technology and really using it for operational needs?
So change 2 decades cannot say, because I got into it research in 2014.
But there was a time when you were in the armed forces and the Air Force, and you were seeing and utilizing those resources. So what change have you seen now for current servicemen?
So when I first really got, which I recollect, indigenous technology, my first brush was when I was doing a detachment and we saw ELH taking off in front of us. It was a huge challenge because they wanted to go on detachment. They were waiting for a transport aircraft to take their ground equipment. Without that, they couldn't go. And today, ELH is one of the finest flying machine despite some challenges. And we have 400 plus aircraft in our inventory. So a huge transformation. But if you see how we were apprehensive of ALH and today we are going into LCA program, the challenges I believe are still there. But the attitude of Indian stakeholders has changed a lot. But I think there
in
are
a good way, or in a good way?
It's a good way because they all want to succeed. But I feel still they do not understand the technology trajectory of a success in aeronautics program, be it the fighter program or the transport aircraft or the aero engine program. So if we have to really become a aeronautics self-reliant power, we will have to understand the technology trajectory. And when we talk of aero engine, I would really try to emphasize or try to bring out that what we need to understand to be successful in an aero engine, how as a nation or the various stakeholders have to think.
Got it. So coming back to Kaveri, when was it inducted, and where are we now when it comes to our getting in the process of getting our own indigenous jet engine?
So allow me to go back prior to the Kaveri, when we tried to tinker with the aero engine, not many people really go deep into it. The first brush of Indian engineers in the aero engine domain was when India was denied engine for the Marut engine. And then we decided to go back to the old Orpheus 703 engine in India. So we installed, which was a Hunter aircraft engine. We used Orpheus 703 engine. It had about 4,800 pounds of thrust. So our engineers decided to upgrade it because with these two engines were fitted on the Marut. With two engines also, it was relatively under par. So they started doing design improvements, and there was a proposal first to improve the thrust of the existing Orpheus engine, and the second proposal was to fit a reheat on it.
Where was the Orpheus engine from?
Orpheus was a British engine, and we had British aircraft Hunters, and we decided to use some of those old Hunter engines and install them on Orpheus. So this aircraft, finally we were able to fly Marut. And remember, so now here the technology trajectory of Orpheus and Kaveri, you will find similarities if you understand that part. We built a Orpheus 703-700 1700K, 703-1700K, which was an upgraded engine, proposed to be upgraded engine of Orpheus engine. It was supposed to have a 5720 pounds of thrust. That was a proposal, and work was done. When the engines upgraded, they really had to, do the internal changes in the engine. Now remember, when you do internal changes, you learn a lot of things. So, there are three phases: upgradation, modification, upgradation, and indigenous development. So modification and upgradation, modification was done and upgradation was going on in the Orpheus engine. The third phase could have been indigenous development had we continued with the Orpheus engine and then followed up with the indigenous engine. But that did not happen.
Why not?
Because the Marut project was discontinued. Now, that part, in fact, this modified engine was certified in December 1973. And that was the time we were closing the Marut project. So, if we had taken a strategic technology trajectory, we probably would not have closed it without collating the data and launching the follow-on program. Now, this part we will, when we talk about, Kaveri, we will have to understand. When the engine...
This was which year?
1973.
1973.
Yeah.
And when was Kaveri inducted?
No, Kaveri is later. Now I am telling you the history of aero engine development so that we understand where we could have done better. That upgraded engine could not have... Remember, we have been asking some of the performances which sometimes are unreal, too much of an aspiration. Whenever you design and develop, you have to be aspirational, but not so much that
your time frames has to be well managed.
No time frame. I think technology trajectory, if you understand technology trajectory, you will be more realistic in it. So that's why, in fact, I have been recommending many times that we need to have a R&D vertical within the defense forces. Not only in the defense forces, we need in DMA, Department of Military Affairs, Headquarters, Integrated Defense Staff, and upgradation of design directorates in the Indian Army, Air Force and Navy to research and development vertical having that. So with that, we also tried to get engines from other countries. There was an effort to get French engine, Russian engine, but I think somewhere we gave up. So having that, once you begin a technology development, you should always have a phase 2, phase 3. Spiral development has been lacking in our program.
Got it. So for our LCA Tejas, what engine are we using?
Now, come back to your Kaveri engine program, which you are saying, LCA Tejas engine. We are using LCA Tejas Mark 1A. We are using GE404 engine.
That's
And
from General
General
Electric.
Electrics from the United States of America. GTR is a gas turbine research establishment, which is one of the laboratory of DRDO, and they're based in Bangalore, and they started this project to develop it. And since it was the first ab initio development project, SNAGMA was taken as a development partner. After some time, what happens when you hire foreign consultants? Sometimes they ask for money, and there was some disagreement on the cost. And SNAGMA moved out of it. Now, when they moved out, there were technological challenges in the development. So this happened 2006. SNAGMA joined, but very soon after some initial consultation, they moved out. 2007, we decided to go for G404 engine. Now, remember the impact of import. How many engines you import, it has an impact on your indigenous program. The moment we went for import, slowly, in due course, the funding reduced for the Kaveri. Later on, we will talk about it. And within 1 year, 2008, it was de-linked from LCA. And those days, I think you can understand, because developing a fighter aircraft and engine together is always risky. But so be it, it was de-linked, the funding gradually reduced. I think many times the DRDO used funding from internal budgets or limited funding allocations. Now, slowly that Kaveri became a secondary project, not a primary project.
Is that because there was a failure to integrate it with LCA Tejas because of the thrust when it comes to Kaveri?
Yeah, see, generally if you see the engine which we are using, I think that is 75 to 78 kilonewton engine of G. And Kaveri was somewhere close to 70 kilonewton.
So 71 versus 70?
No, I think the current one is close to 75 or 78.
GE is 75, you say. And
75 to
Kaveri
78.
was able to give you 70.
Close to 70, and it had some design issues. So, ideally speaking, there should be a technical review of an engine. And, if you're really looking at a strategic self-reliance, you should have been fast-tracked. This is how, if you are looking at a long-term self-reliance, it should work. They were funding given, and very recently there were other problems also. We did not have a high altitude wind tunnel. So this wind tunnel, we had to really go to Europe.
Like a testing facility.
Testing facility.
So we lack testing facilities when it comes to bringing our jet engines to place.
So there are two testing facilities which are of significance. One is a high altitude wind tunnel, which I spoke. Second is a flight test bed. Now, all these, let's say we have to do testing in Europe or Russia. First, you have to negotiate the cost. Second, you have to check their availability. Like Russia, when we wanted to test, Ukraine war came. So that delayed the testing by some time.
Because you're dependent on the another
You
country.
are dependent on something. And remember, that investment, which is, if it is goes on to testing facilities, as I said, tomorrow we were able to develop. We will be, supporting so many engine products which are there. Let's say transport aircraft, helicopters, UCAS. All these will benefit if you have those facilities.
That ecosystem.
So I think that will become critical pillar. And if we really have to become, if you saw the recent wars, the higher level of dependence becomes a major limit.
It's all about supply chain when it comes to today's war, because it's the capacity of helping yourself when you really require. So we spoke about Tejas. What about AMCA? When we are in the process of inducting AMCA, what kind of engines would be in the AMCA, sir?
Okay, currently we have decided to use G414 engine, which is close to about 98 kilonewton thrust. So initial AMCA Mark 1 will be fitted with the G404 engine. But in future, when we have to go, We will be looking at
Mark II, basically.
Mark II with the indigenous engine. So when you say indigenous, it will not be designed entirely by India. We will have to look for an international partner.
Jet engines.
Jet engine. So, probably there are three potential partners as of now. One is GE from US, Rolls-Royce from UK, and a French developer.
According to you, which is the best jet engine in the world right now?
No. Russians also have been pitching their engines, but it's not the best jet engine. As a nation, you decide which engine you want.
No, but if you were to
see, we are what you must understand is we are looking for a fifth generation fighter, fifth or some capabilities of sixth generation. So some requirements are there. We want a highly efficient engine. We want engine which can give us super cruise. Super cruise means without using an afterburner, you can go supersonic. Now that will be crucial for stealth characteristic and high performance. That's a aspiration, but where we achieve, and that will which engine will depend on what is the all-up weight we decide, what is the weapon configuration we decide. So within that configuration, whether we want to go for an existing design or probably we may have to. Currently, we are looking at a 100 to 110 kilonewton engine, which probably will have to be designed because most of the engines are above 120 or below 100. So let's see how we finally decide. So future will depend on collaboration. But now I want to come back to Kaveri engine. Kaveri engine has reached a stage where now we are talking of a derivative engine. What is derivative engine? The Kaveri derivative engine is the engine without the afterburner. Remember, our internal design and afterburner was facing challenges. So derivative engine is a non-afterburner which will be used on a UCAV, which we call it a RPSA, remotely piloted strike aircraft, which is being developed by the Aeronautical Development Establishment, a DRDO laboratory. But the challenge or the problem with the derivative engine is RPSA program itself has not been approved. So since RPSA's program has not been approved, this derivative engine, of course, development will always provide a pillar. You have a proven engine, you can always develop a RPSA based on that or a UCAV in future. But my issue is our pillar will be the fighter aircraft, which probably we are going to do it. So I think we need to focus on, let's say, hypothetically, if I was looking at a national interest, I would have gone with an aircraft design, which probably uses 75 kilonewton engine, 275 kilonewton engine, and reduce the weight from, let's say, 25 tons to 23, 24 tons, and develop an indigenous, which is a fighter with indigenous engines. But that requires a very systems engineering approach and a national approach, how to build a systematic manner your indigenous capabilities.
So what are the current technical specs of a Kaveri engine, sir? No. And do we really require it is the question.
No, see, today, current our aircraft designs, we need, let's say, 75 to 80 kilonewton engine for LCA Mark 1A. So if we have to do it, I think, there was a proposal from Godrej to upgrade the Kaveri engine. In fact, one more private entity had proposed, I think L&T or Bharat Forge, somebody had proposed where they said, we will work with DRDO or GTRE to upgrade the engine. I think that phase is very, very important. That has not been articulated
like
so
a private
far.
collaboration.
Private collaboration to speed up that. No engine program. I was talking to Commodore Maulankar, to understand why do we give up halfway? He said, no project is ever closed without achieving the reasons for failure, and you have a next variant being worked on.
So I still haven't understood. Have we closed the Kaveri chapter, or is it still in the pipeline, sir?
See, when we are talking of a derivative engine, it means it's not talking of a afterburner variant. And it has been indicated on various manners that DRDO is focusing only on a derivative engine. Whereas what we need is an afterburner variant. That is what we need. Derivative engine will become relevant when RPSA program is approved. So I think we must focus on Kaveri afterburner variant, either by launching Kaveri 1.2 or Kaveri 1.1 or Kaveri 2. It is the need of the hour, because and then we should also look at upgradation of this engine from, let's say, currently 75 70
full
Newton to, let's say, 80 Newton, and in future going to about 100 to 110 kilonewton.
Fully indigenous?
Or that should be our endeavor, because unless you have your own plan, we will always be dependent on it. And one more thing, I think, when I also believe that DRDO must do the course correction in the derivative variant, because let's say derivative is being developed for a UCAP, and similarly in future we will need a derivative for HAIL UAV. But HAIL UAVs require a turbofan engine. Turbojets will have a lesser endurance, so they will have to have some sort of plan to use Kaveri as a base and develop a turbofan variant to have a highly efficient long endurance engines.
So what I've understood is that Kaveri engine started off on a good pace, but when we realized that it was not the most apt engine for the LCA Tejas, we put it on pause. And there were other problems as well, setbacks, such as there were lack of testing facilities, we didn't have wind tunnels or even high altitude testing beds, and the material science didn't work through as much as we needed, the kind of material sciences. But the biggest problem, what I've understood, is the problem of thrust that was unable to provide by the indigenous Kaveri engine. Is what I've understood. Is it correct, sir?
No, my view, the biggest problem is we need to have understand the technology trajectory and persist with our indigenous program, decision making, roadmap following, every technology, high technology, complex project will have challenges.
Will fail until
or it will have setbacks.
Setbacks.
So managing setbacks and moving ahead is decision making in that is critical at this phase. We have already achieved many technologies, and any pause at this phase will take us back from there. So there should not be pause, there should be continuity while we are looking at collaboration. So unless you have an indigenous program being run, I think we will be missing out the greatest opportunity of our recent time.
If we need a successful indigenous jet engine project, what timeline are you looking at, sir? What is the timeline that India should look for and give ourselves in order to create an indigenous system?
See, I'm very I'm not qualified to give timeline, but I'll tell you lessons from ALH program or lessons from many aeronautics projects around the world I have seen. When you achieve the first milestone, and the first milestone in India's aeronautics history was ALH program. ALH program, we took about 3+ decades, and it is still improving. So it took another decade and a half to really come to some stage. But ALH program became the stimulant of development of LUH and LCH. Now you have a attack helicopter, is the only helicopter, LCH is the only helicopter in the world which can operate in high altitude terrains of J&K. Now that was a product which came in less than about 10 to 12 years or maybe 15 years. Your development timeline is halved. Similarly, in the aero engine, now I draw parallels to it. We have done all the hard work today. If we don't launch Kaveri Mark II or Kaveri Mark 1.1 or Mark 1A, we would be doing it. I think even inaction would be a mistake. So it's a time to act on a Kaveri Mark, Kaveri engine. It will be, it can be a pillar for future generations.
Before we transition into the next segment, let's lighten our conversation and you tell me, sir, what are the helicopters that you have flown over your career, sir?
Okay. Um, I have predominantly flown Chetak Cheetah helicopters. So across India, if you see northern borders, northeast, deserts, plains of India, even we used to have a float aircraft, which was a Chetak fitted with two floats, and we would go and land on the backwaters. So quite a fascinating journey of a helicopter pilot, because you save lives. You save lives. You provide emergency supplies. You really are lifeline for people sometimes. It was a really a great experience, having flown more than 4,600, 700 hours. It was a experience by itself. Also, I had an opportunity to serve in NCC National Cadet Corps, so I flew Zen Air, flying Zen Air. It's looking at the future generation, how they perceived flying. Uh, and it also made you realize how difficult it was for our instructors to teach us, because when you sat on that chair and you saw how a young student will behave, it was quite a revolution, because you're teaching school kids. So it's very interesting.
So lately we've been seeing a lot of crashes. Why do you think that is?
See, I'll tell you, there are no excuses for crashes. So I will not take anything. But I also want to tell you the kind of focus sometimes it comes on Indian aircraft. We need to first look at our own weaknesses. That is one part.
When it comes to maintenance?
Design, maintenance, design improvements. We need to look at it. Second, also we need to be careful how the narratives are being built against India, because you are now becoming a aviation manufacturer. So global narratives can be against your country. So I think we need to be a little cautious whenever we do it. We need to be objective. I'm sure we must be very strict with ourselves, but we should not forget that there is an international competition also could be at play to create a narrative against your product. So I think we need to be a little more balanced in our critique, very objective, have a lessons, but while being aware how narratives are being played. And that will help us prepare better for future. Internally, we need to be very objective in our
Connecting to my previous question where I asked you about what helicopters you flew, to ask you what helicopter would you like to fly now when you see what do you call all our
future.
the current helicopters. Which one do you
Helicopters.
think is a good match for you, and you think Group Captain Narang would really enjoy flying?
See, I have not flown tech helicopters, so I would like to fly LCH. But I'm also view how Indian aeronautics industry is. I would like LCH to be more, should have a capability to have a counter drone capability, counter drone swarm capabilities, networking capability, manned unmanned capabilities. That should be our plan for developing an LCH Mark II, LCH Mark III, maybe autonomous or optionally manned LCH. So I think we need to always be ahead of technology curve. We must understand the technology trajectory, and technology trajectory is talking of optionally manned, manned unmanned teaming, counter drone, counter swarm capabilities, and better indigenous sensors and Atmanirbharta in many of the critical technologies. So I think LCH with Indian futuristic capabilities.
Would that be a stealth helicopter, sir?
I will say stealth will be later, because it's not a stealth design. But I'm saying let's
Is there any
develop
stealth design in when it comes to helicopter
that
worldwide?
I think I'll have to really deep dive into it before I suggest stealth. But current phase, as I said, I'm looking at LCH, with the counter drone, counter swarm capabilities and man-unmanned teaming, and because if you're able to send unmanned platform ahead of manned aircraft, so you have reduced threat to yourself. And let's see.
So briefly, I want to speak about fighter jets.
Yes.
And we have a squadron of about 30 squadron fighter jets of different fighter jets. We have options of Rafales. We have Tejas now as well, LCA. Uh, what is your current thought on our fleet of fighter jets, and how can we improve?
See, first thing, I think we are working on a lot of indigenous projects. And fighters, as you have seen in the Ops Sindoor, the Indian fighters were able to do standoff capabilities, standoff missions they were able to undertake. An ideal fight, so area which India will need to really work on it. We need to ensure that our fighters are in future are capable of manned unmanned teaming. We have more indigenous sensors and payloads. The integration and adaptation should be faster than what it is. The development timelines have to be improved. We need, let's say, our AMCA project is crucial for our future of our fighter aircraft development trajectory. But in the immediate future, I am looking at LCA Mark II. So LCA Mark II, we must have a plan B and plan C, because fighter of future will require not only standoff capability but also manned unmanned capabilities. In fact, I am looking at fighters which are optionally manned, because
That's the future. You wouldn't want to risk your soldiers.
so I'm saying, if the pilot is required, we have an option. And if we don't have, I don't want to predict too early, because sometimes the technology takes time unless there is some disruption. So I don't want to risk taking, making a presumption which may be too idealistic but may not be a practical one.
We haven't seen an unmanned fighter jet yet.
It's not easy to replace a man. Man may be very, may not appear that, but I think God's creation sometimes have extreme capabilities which machines, if you have to imitate, are not easy to do it.
How do you rate Indian Air Force's fleet when it comes to fighter jets?
See, Indian Air Force has raised an issue of strength, issue. And I think that's why I'm saying the technical review of our indigenous projects like LCA Mark II, LCA AMCA, your aero engine. In fact, one area which probably we are not paying attention, two areas I think where we need to pay more attention is naval fighter aircraft and unmanned combat aircraft and unmanned HAL UAVs and MALE UAVs. Because unmanned domain and naval fighter are the two biggest areas, plus engine. So three areas India has to really tighten its shoes. Otherwise, we are going to have a challenge.
We will speak about naval platforms. Before that, I still haven't gotten an answer of you rating the current fleet standards of the Indian Air Force.
Indian Air Force is manned by world's best pilots. So they would like more fighters. They are very professional team. And if you see the way we destroyed the 9 terrorist positions, remember we did it without neutralizing their air defense bases. It cannot be done with extreme professionalism. So so number wise they would want more, technology wise they want more, because air war is always technology sensitive.
So a very tiny question. We've been talks.
Here I just want to do. You're talking about this thing. Here we need
fifth generation.
No, first we need is a data network, aerial data network. The software defined radio.
That was a failure when it comes to operations and
so I won't say failure. I'm saying we need to work more, because you need to adopt new technologies. You need to modify these things. Let's say blockchains are coming, quantums are coming, or even just basic software defined radios. So I think since Air Force is a technology oriented Air Force, the aerial data links, will be crucial in future, because aerial data networks are not only required for manned fight, it's even between manned and unmanned operations, swarm operations. So it will become crucial in the times to come.
For a layman, can you explain why data network is important in a fighter jet or any other program as well?
See, fighters are not one. They work in packages. Sometimes you have to pass information, sometimes you have to pass data, sometimes you have to, communicate with each other. And if adversary gets a whiff of it, your effectiveness of the project, mission gets reduced, and which no one would like to do it.
What is the intel that has to be
Has to.
safeguarded?
Secondly, when you are
No. What is the intel that you need to safeguard? One is your presence through the radars. What else?
if somebody can track your position, somebody can track your communications, your intent gets compromised.
Got it.
You can do it with other means, but that's not the most efficient manner. You should have all capabilities. Future, if you are talking of a data link, let's say I am operating, HAL is developing a combat aerial teaming system, which is a unmanned teaming platform, where manned fighter will control the unmanned fighter. Now, if they themselves get compromised and somebody can make it land or it can confuse it, our purpose will be lost, because that unmanned fighter will have further systems ahead of it. So the data links will be very, very crucial for future war.
Uh, Before we jump into naval fighter, I just want to ask you, we do need a fifth generation, because our neighborhood, our threat perceptions are getting themselves a sixth generation now. But by the time we catch up with the AMCA, it's going to be too late. So we must procure from international, OEMs as well. We have two options. One is a Sukhoi 57, and we have F-35 from the US. Which one do you think is a better fit for our Indian Air Force fleet?
See, first of all, I'm not really qualified at this stage, because let's say Su-57. First, to tell you, Su-57 is the same FGFA program in which India was supposed to be a partner. In fact, we started with the collaboration, but I think we did not really make much progress, and our scientists had to come back.
Because there was no transfer of technology that was happening, so we pulled back, I think.
We pulled back. And in fact, I think we made some payments also, and our scientists went there. So this we have to realize, that whether Su-57 or F-35, the dependencies will be on the OEM.
Dependency would be on the transfer of technology.
It's transfer of technology is a very, very loosely defined. It is how to use it.
Knowledge transfer.
That's again a loosely defined. So you really don't own the technology. You become better user of the technology, or you can have a manufacturing technology.
You co-create.
Production.
You co-create, and in the process of co-creation, you learn.
Co-creation is what we wanted for the FGFA. That would have been co-creation. If that was done, that would have been great. But we did not co-create. Now anything you do is only licensed production, nothing beyond that. And F-35, I expect even lesser. So it is not the future of India. It can only be a stopgap, interim, and the numbers will have to be limited.
Which one would you prefer?
No, now the government has given a clear call. We are going for AMCA. So
that's fine. I agree. But AMCA takes another 10 years. But until then, we can't wait for 10 years before another conflict.
I see, what you must understand is government has changed the policy also in between. They said we will invite private sector to help us expedite. So that expression of interest are being already asked, or that is also a process on.
Which jet would you prefer, sir? Would you prefer F-35 fifth generation
it's early it's early without knowing the.
It's a very loose question, sir.
It's inappropriate without knowing the performance, and it will be incorrect on me to really commit on either side, because this is something which is taken by the Air Force test pilot. And this is only, remember, they are not really offered, otherwise our people would have gone, and there is no RFI on this part. So if nothing of that sort is there, I think it's jumping the gun, and that's not the way I.
So we have been seeing HAL AMCA as an option of fifth generation for India, which is going to take another 10 years. At least 2035 is what HAL says. What about our naval fighter? What are we going to do when it comes to our aircraft carriers in the Indian Ocean region or other threats, mainly that comes from China?
See, naval fighter is something which you must understand. I've been trying to understand what the naval fighter, why is it so difficult to develop?
Before that, sorry, sir, if you can give people a difference between a naval fighter and a fighter for the Indian Air Force.
Okay. Some 3-4 things a naval fighter pilot faces challenges when compared to an Indian Air Force pilot. Indian Air Force pilot has a full runway to take off and land. Okay. He can land at a shallow approach. His runway is fixed. Naval fighter's runway itself is moving. And then it has got, it could be moving not only forward, it could be, shaking in left and right. So naval fighter and the landing runway available to him is barely 170 to 200 meters by length. Takeoff same way. Third thing is he has to land. His landing accuracy has to be extremely accurate, extremely high. So that makes naval fighters land with a very high rate of descent, because they have to engage the hook with the cable. Their hook has to engage with the cable, which will help the fighter stop. So undercarriages have to be stronger, some longer invariably. Thirdly, the view of the pilot. The pilot itself should be able to view below, because he's landing at a higher rate of descent. The structure has to be stronger.
The platform,
because it will be stopped by a hook at one point. If that breaks down, you are into this sea.
Got it.
And you have to take off from a very short distance. Now, within that short distance, you have to carry the payload. So engine performance becomes very critical. Now, this requires a lot of design differences. Now, these, in fact, naval designers feel that if you build a naval fighter from a land-based fighter, it is very difficult. You have to really redesign the fighter. And that's why they have been vociferously seeking development of a twin-engine deck-based fighters. But I think naval fighter available on a ship are limited, because your parking facilities are limited. The kind of weapon load you can carry on a ship are again limited. So combination of weapons, the number of weapons, effectiveness of the weapon. So naval fighter is much more, I'll say, you have to do optimization much more than land-based fighter. Land-based fighter, you can always say, I can have a land attack variant differently, air defense variant differently, or some combinations. You can do changes on ground. You can have more, storage facilities. Naval fighter has to go through the lift to the parking space also, or the maintenance for issues. So there are very, very peculiar teas of a naval fighter. And when you ask me about Indian naval fighter, I'll tell you.
Tell me about the Indian naval fighters, sir.
Okay.
What naval fighters do we use at the moment, and which ones are we in the process of procuring? Or inducting?
Okay, let's understand. India started a naval fighter program. I'll start with the Indigenous project, which is...
start with our current fleet, sir.
Current fleet, we have a naval, let's say, MiG-29. And recently
That's a 4.5 generation?
It's a 4th generation
It's a 4th generation.
And now we are going for Rafale M. 26 Rafale M from France.
That's a 4.5?
That's a 4.5 generation fighter. And remember, naval Rafale and Air Force Rafale. Even F-35 has got naval and air variant together. So it's not abnormal around the world to have a Naval and Air Force variant of the same
Same
fighter.
jet, yeah.
But it requires little more diligence. I said there are too many nuances which we have to understand, and that's why our indigenous development program of LCA Mark 1 Navy becomes very, very important. Understanding of LCA Mark 1 in Navy, or the contribution of the Indian Navy's designer, Commodore Balaji, and team of ADA experts, and the team of Indian Navy which contributed in the development of LCA Navy, you see with you, it becomes important. 2003, it was added on to LCA project. Remember, LCA project started in 1984, and 2001 LCA had done its first flight.
15 years it took.
And
17
yeah,
years.
but what is more important is, it's after the first flight of LCA Navy, 2 years after that, LCA Navy project was approved. So, which the naval designers, especially the naval test pilots, feel was not a fair thing to do. There should have been joint development program, and preferably Navy related features should have been taken into consideration. In fact, naval designers believe that when the Navy project started, our LCA project benefited from the naval project, because naval's precise requirements helped improve performance of the naval, normal land-based naval.
So you saying there should be a simultaneously work on both the naval platforms and as well as the
Yeah, if you are
land
looking at the
platforms.
both, otherwise Navy people preferably want the first naval design to be done, because they always say Rafale started as a naval fighter and then we came with the land fighter. 2012 first flight of naval LCA took place, and remember, a lot of hard work was done, because they had to develop modified control laws. The workload was reduced by using more better control laws, and in fact, the Indian Navy, at INS Hansa Goa, they developed a special ski jump facility, because we had never developed an aircraft. We have only operated an aircraft. So, which, how to develop an arrestor hook, how to develop a strong undercarriage, reservoir power, take off from 200 meters, abrupt stop, all these capabilities had to be tested and validated through a land-based testing facility. And then there was a plan to develop a naval LCA Mark II. But naval LCA Mark 1A is a 13.5 ton, fighter aircraft. Its payload carrying capacity was limited. But still, there was a suggestion from Admiral, former Chief of Naval, who was a fighter pilot, Arun Prakash, and even test pilot Commodore Malankar, that some number of LC Mark 1 could be introduced to develop the data. Remember, whatever you learn, if you don't induct it, the learning goes. The way we lost Marut, the way we lost our aero engines, the project closing has to be done in a manner that you have operational data collected to develop the next variant.
Yeah.
And naval fighter program is reaching again that stalemate, where whatever we earned through all these last 2 decades, it could be lost if we don't have a future development program. Now, what Navy is seeking is, first of all, there was a proposal to develop LCA Mark II Navy. There were two, the prototypes were to be developed, but Indian Navy did not join, and they instead proposed development of a twin-engine deck-based fighter, which is a twin-engine variant of upgraded LCA.
A fifth generation.
It's a 4.5 generation. It has got somewhere close to 4.5 generation. It's got, I will say, canard. So probably there are apprehension that it will increase the radar cross section area. So and Navy has also not joined the Advanced Medium Combat Aircraft program. Now remember, LCA Mark II and AMCA are both approved projects. If TEDBF has to be pursued, it has to be given an approval separately. So, which has not been given so far. In fact, if you see, last year, AMCA project was approved with a allocation of, I think, 1,500 crores. initial allocation. So it's moving forward. TEDBF is not moving forward. LCA Mark II Navy has not joined. So we are in a stalemate in the naval fighter development program. The decision is very important for India's Atmanirbharta, because if naval fighter has to really make progress, we have to really decide which naval fighter has to be done, and Indian Navy has to come on board. Any delay at this stage probably will have a long-term implication of self-reliance in naval fighter development program. And finally, let's assume we get a Rafale TOT. Here, I want to understand. Want you to understand. We got we were manufacturing MiG-21. We made 850 MiG-21s. That did not make us self-reliant. We had to go back to the LCA project. The development of LCA Mark 1A has given us an opportunity to work on indigenous project. We should not let it go waste. It's a lot of hard work done in developing indigenous capability. It's time to leverage that. First, one by, let's say, inducting certain number of LCA Mark 1A, which could be used as a LCA trainer. So let's say you induct LCA trainer variants or whatever Indian Navy feels in certain number, let's say 6, 10 aircraft. Because that data will be required for indigenous capability. It's never a wastage of effort.
So you're saying Indian Navy has to be vocal about their requirements when it comes to fighter jet and really sanction the project, whether it's an AMCA project or a LCA
TEDBF.
Or a TEDBF as well.
Because it's important. It's a national requirement. It's not about Navy. It's about India's self-reliance trajectory. Because long term, when you're talking of China developing 5th generation, 6th generation, we will only be able to match threats from China or China-Pak combined. Remember, today Chinese are talking of J-10C, JF-17. Now they are coming with J-35. The threat is going to increase. And let's say we start assembly lines, we will be depending again on foreign OEM. I think import has to be limited now, and indigenous has to be given impetus. And today is the time to give impetus, not later.
Got it. So quite an insightful conversation on these two subjects, which is very important as well. We also have to speak on another subject, but we'll keep it for another day because it's a podcast on its own. What we need to speak about is India's growing need for aviation. We have so many airports. We have 140 plus airports and schemes such as UDN. We order a lot of aircrafts as well from the two dominant duopoly, which is the Airbus and Boeing.
Yes.
Our conversation before the podcast, you mentioned how we need an indigenous program here as well. This will be a podcast in itself, and we will have you over again on the subject because it will take another 40 minutes to discuss this. Having said that, this was a very insightful conversation. I want to take this opportunity to share your books, your first book, which is on the India's quest for UAV and its challenges. And if you want to speak a little about the book, sir.
See, book, I think it's again thanks to Air Force. In fact, I was told to do study on UCAVs. When I started study on UCAV, I realized there is no UCAV in the world at that time, because still the man has not been replaced in a fighter. So then I said, India's quest for UAVs, because we know where the world is going, but it is more important to find out where India is going. So I learned in this book, I studied China's UAV program, Pakistan's UAV program, UCAV development program. What was more interesting part was, what are the challenges to indigenous design, development, and manufacturing in aeronautics and drone technologies? Because that really took a lot of time for me to understand the challenges. And then I realized, after having realized the challenges, it is more important to come up with some roadmap. So it was little challenging for me, because we are not natural, scholars by some standard. So it was a lot of hard work to understand and a lot of guidance. I remember I sent it to one of the former air chief, and he said, it looks like a science fiction. So now I think I'm so grateful to him, sir. He really made me realize that I can't write anything and everything. I had to be very responsible. I had to be very it must be validated as to how we do it. So a lot of learning, and I think that has helped me understand Indian defense and aeronautics industry and the drone industry. I had good interaction with drone startups, our academia. So a lot of learning from public sector, DRDO, HAL, private sector companies, the startups, academia. There is enormous potential in India. We have to really do the course correction. I think ownership, leadership, and decision making. I say again, ownership, leadership, and decision making. Here, if you allow me, I would like to talk about year of defense reforms here, if you allow me.
That's my favorite subject, so please.
I think Indian defense industry is passing through transformation, and Ministry of Defense has declared 2025 as a year of defense reforms. There are four momentous, or rather critical reforms Indian Defence Forces, or rather Indian government, has to think how we can do it. I think one part is we need to bring the technology experts in the Indian administrative service, heading the, let's say, Department of Defence Production. Now, how do you bring the technology experts? They don't have to come from outside. There are a lot of administrative officers who have a technology background. So I think they can do a small vertical within them. So I think internal reforms. These people should have served in, let's say, DPSUs. They should have served in, let's say, R&D organizations. They should have served in the defense forces to understand the technology trajectory, and they should have an understanding of how our adversaries are moving, so that tomorrow when they take the highest positions, they are not looking at others first to tell them what is happening, understand on the job. They are empowered to now take decisions, because decisions, like, let's say, if testing facilities have to be done, if decisions are taken faster, a lot of future development can be expedited. The second reform I think we need is techno finance experts in the defense finance. Defense finance is always receives less attention. They are the core of technology, procurement, but budget. If they raise questions which probably delays the project, and if they understand that technology trajectory, they can be enablers.
Sure.
And remember, technology is time sensitive. We have seen so many projects getting delayed, and we have said it's outdated now. So I think they also are part of the system. Remember, best machine works where the lowest or the smallest part works in the most efficient manner.
True.
So I think reforms in defense finance with the techno finance expert. Third part I feel is within the defense forces, we need a research and development vertical. Now, within the defense forces, there are three elements we have to look at. One is Department of Military Affairs, which is a very powerful organization. And there, if we have a research and development vertical, it will do a lot good for the Indian Defense Forces. The second is Headquarter IDS. It has some sort of technology perspective and other things, but I think we need a R&D vertical within the Headquarter IDS.
Right, you absolutely right, sir.
And just last point is upgradation of the design verticals of Indian Army, Indian Air Force, and Indian Navy, from design vertical to have a vertical of R&D in three cells. So these are the.
You're right. When it comes to year of defense reforms, the most important thing is modernizing and giving our armed forces the right equipments they need to fight. And for that, you need R&D, and you need to study the emerging technologies and the technologies that our servicemen would need in the future. Our honorable
fourth, if you allow the fourth reform, which is I take this.
I mean, there's so many reforms we need.
No, the fourth one is Defense and Aeronautics Commission. Here, everybody is equal today. If we have a body, either you call it a committee, empowered committee, or a commission, we need this, because first among equal becomes a challenge.
like a joint collaboration when it comes to aeronautical engineering or our
See, the
aero
decision,
requirement.
why space is doing well is there is a decision making body, higher body. We need similar structure. It can be in different structure, but we need Defence Aeronautics Commission or empowered committee.
Got it. So you suggested some important reforms that we need to have a, Atmanirbharta in aeronautical, aerospace, basically.
Yes.
Absolutely right, sir. Very insightful conversation. Learned a lot. I'm sure the audience has a lot of takeaways. I hope the right people hear it. And all the sir's book that sir has authored would be available in the description below. Please get yourself a copy. See if you find it interesting. And yes, thank you very much, sir.
Thank you for inviting me.
Pleasure to have a conversation.
Making me go deep into some of the things, and it was learning with your curious questions.
We look forward to having you again to speak on another subject. Thank you very much.
Thank you.
If you enjoyed the episode, make sure to like, share, and subscribe. Until then, keep reimagining yourself and know that the power of change lies within you. Jai Hind. We at DOAP are working really hard to take this podcast to the next level. Our guests are going to get even better. Our production quality is going to get even better. And hopefully, I'm going to get even better too. Most importantly, we are committed to being consistent and continue to do what we love the most. Until then, keep reimagining yourself and know that the power of change lies within you. Jai Hind.